Hello, this video aims for demonstrating BIMS, a software for detecting online events over graph streams. The software is byproduct of a research we are doing now in database group of EECS departments at Washington State University. The video consisted of two parts: overall idea behind the software and software functionalities. Let me illustrate the usage of the software by showing an example of our Panama dataset. Assume that a user wants to discover most active offshore tax havens of Asian companies since 1965. Then the user fixes the nodes of interest based on the query. Here, user should fix Asia and active as two focuses of interest. Note that each node may have a type and a set of attributes. For example, continent is the type of the node and Asia is an attribute value. By running BIMS, we can find most frequent events. Here, the most active jurisdictions so far are British Virgin Islands. Event detection over data that are modeled as graph has many other applications. To name a few, in cyber network security, in social networks, and in urban environments. Conventional event detection has been done for years. They have considered sequence of items or tuples as an event. However, a set of heterogeneous entities and their interactions are more involved than item sets and tuples. Furthermore, we are dealing with an online setting. Therefore, we need an efficient algorithm that works in one pass. If you are in a dynamic environment and want to discover frequent events, BIMS can answer two sets of your questions. First, what are top K most active events so far? And second, what are top K most active events over the last L snapshots? The algorithm used behind this software has a boundedness guarantee. That is, no matter what is the size of the original graph, time complexity is the function of the affected area that affected by the new update. It has also an interactive user interface that will show it next.
Let's play
Software,
with that.
by seeing an example of our Panama dataset, we select it. It takes some time to load the data and it shows the statistics of the dataset. Then we select some focuses, as I've said before, Asia and active. We want top 3 bounded by 4 edges, and the distance of nodes from focus is bounded by 1. We don't change other default parameters, just select accumulated mode, that is active events so far. Furthermore, we should select the interval of updates that support should be reported as snapshots. The algorithm uses a cache for dynamic load shedding. We also don't change these two. By clicking on play, we go to display window. We have two modes: jumping to the last state or monitoring a step by step. We click on fast forward to go to the last state. After a while, we have the frequent events. Focus nodes have a star beside their labels. Also, we can hover on nodes to see their attributes. We can click on nodes like country to see their matches. In addition, we can see the support trend of each top K pattern here and total line chart, which is the sum of all other supports. We can also see the performance of the algorithm. In performance window, number of support verification that has been done and the memory usage for incremental maintenance. Okay, we go to another example. This time from citation, we set focuses as after data is ready, we set focuses as data mining and data driven recommendation. Event size bounded by 3, diameter could be 2, and window size means that each 5 years we set sliding window mode and click on play. This time we go window by window. The first top 1 pattern. The first top 1 pattern is system venues, that most cited data-driven recommendation. In the second window, from 2005 to 2010, DB is the first one. And in the last window, AI is the most frequent. We can see the support trend.